Can you all see the screen? Can see the screen? My screen? Okay, can you hear me clearly? Can you hear me clearly? Okay, good. Okay, let us start the class. So good evening. Today I'm going to explain regarding the assignment. Each and every group will receive a different question, okay, different problem. Each group consists 5 students. This is one of the example of the problem. Okay, the questions are below here, down here. Let us see one by one. First, determine the decision variables. This one I went through with you already. Determine the constraints and formulate a linear programming model. Okay. 1, 2, 3 you can do. 4, there are some terms here. I ask you to define the terms. Optimum solution, optimum value, select variables, range of optimality. All this I have taught you before. Range of feasibility, I didn't teach you. Okay, that is, you can omit that. You don't need to do that. You don't do for E. Don't need to do. Shadow price need to do, binding constraint, non-binding constraint, feasible region. All this you have to do. What I'm asking you to do is write the definition. When you write the definition, you no need to use your own word. You can take it. It is not you can. You must take from some sources, some reliable source. For example, ebook, any book or website. When you write the definition for each and every term, you need to give me the reference from where you take. Okay, that is one. Transform the linear programming model to standard form. Okay, standard form I teach you. Using graphical method, analyze the phrases defined in form. So graphical method here means you have to draw the graph and find all the term here, all the term except for range of feasibility. Okay. So you need to use the graph. Use graph and find the all the terms here. Using QM software, find the phrases defined in form. Please mute your mic. Who is that? Please mute your mic. Somebody is not muting. Who joined now? Why suddenly there's a background music? There's a background sound. Who joined now? Please double check your mic. Okay. I hope everybody has mute. Can hear me? Everybody can hear me? Okay. Can you see the screen now? So I'll continue from here now onwards. I continue from here onwards. Now for using QM software, number 7, using QM software, find the phrases defined in form. For example, so this is QM software. You go to linear programming. Let's say let us put some constraint here. Let me put some number here. T A 2 4 1. Sorry, here would be 10 282 1 400 40 and 40 and 5. You solve this. Let's say this is your modeling, linear programming model. I can't see the screen. Can you guys see the screen? Can you see the screen now? Can, is it? Can see? Anybody? Yes, no? Yes, okay. Then if anybody cannot see, maybe their system is wrong. Something setting is problem. Please check. Okay. So if you have this model, let's say this is your model, then you solve it. When you solve, you have 6 sections here. You have 6 sections here. 1, 2, 3, 4, 5, 6. Okay, 6 sections here. I want you to go for section 1. This is section 1, linear programming result. You save this or print this in PDF form. In PDF. Go to section 2, ranging. This ranging also you save in PDF or print in PDF form. Okay, all these I want you to save all in PDF form. Which one I want you to save? 1, 2, 3, 4, 5, 6. There are 6 portions in your answer. Save all these 6 portions. That is your answer. That is the answer for 7. The 7 answer will be completed when you give me all that 6 portion. Okay, when you solve, you can see all the 6 portion there. Question 8 and 9 no need to do. Number 10 you have to do. Number 10 just interpret your result. Okay, if your question what is this, the decision variable here, the decision variable here is prune olive. The decision variable here is prune olive and regular olive. I think that is the decision variable. Some you may have decision variable as table and chair, as simple as it. So when you want to interpret the result, you just need to let me know how much olive, regular olive and prune olive you have to produce to get the maximum profit, something like that. Okay, just let me know how much you use the resources, how much is left, something. Okay, no need to write an essay. It's just briefly explain to me what is your findings. Number 4, E no need to do. 8 no need to do. 9 no need to do. Later I will highlight again in the group, something like that. That is regarding question. Now how are we going to submit your answer? This is the front page. This will be the page 1. Okay, front page, cover page, whatever. You write your member's name here, metric number, section. Okay, if I'm teaching, write my name here, section 1 and 2, 2 and 3, Dr. Yoza name. Okay, this is Word, so you can delete either one of the name. Don't write both name and circle one name, no need. Okay, I suppose you are expert in Word. Write all these things, fill up everything, save it as PDF. Clear instruction, save it as PDF. Second page would be your question. I need your question. Don't give me answer only. I need your question to see your answer is appropriate or not. How am I going to answer mark your answer without looking at the question? Because there are so many questions. I cannot browse through one by one. So when you submit your assignment, submit with your questions. Page 2 is your question, which is already in PDF. Now, page 3 onwards is your answer script. So this time I allow you to type. Okay. So you use Microsoft Word, type your answer and save it as PDF. Determine the decision variable, you can type in Word and save it as PDF. Determine the constraint, you can do the same thing. Formulate linear programming, you can use the same thing. Type and define all these things, you can write and give me, type in the Word and with the reference, save it as PDF. Of course, you can do continuously, one after 1, 2, 3, 4, 5, something like that, okay? And then finally you save it. Now, until 5, you can do in Word, but until 6, once you go to 6, you need to use graph paper. In the graph paper, you need to draw things, and then you want to solve it. Okay, here you can use handwriting. Okay, it's up to you. I leave it to you. But I only prefer handwriting for maybe graphical method. The rest you can use. I think you can use some the Word. Even I think calculation they have some method. I think there's a application. Okay. You use graphical method. Use graph paper for graphical method, and then I want you to go to this application, Cam Scanner. Take a picture of the graph paper. Use this Cam Scanner. Through this application, you take a picture. Of course, you have to install this in your phone. And then, if you take a snap from this application, it will nicely scan your graph, neatly give a better presentation of your graph, a bright presentation, not a dull presentation. Okay, then it automatically will save in PDF. Okay, so for graph paper, you use this application. For QM software, I told you just now how to save it as PDF. Okay, you just go through there, and when you click save, you can save as PDF. I think that's all regarding assignment. I try to submit all the assignment. I try to give the question by today. Once you save it as PDF, the front page, the question in PDF, and all the answers in PDF, you go to any application in online, PDF merge, small PDF, there's a lot of application. You put all the PDF form, merge it as one PDF file and send to me. How are you going to send to me? You're going to send to me by email, or I prefer Messenger. Okay, I prefer Messenger in group, in Facebook group. You can send to me there. Don't upload in the group. Upload personally for me in the Messenger. Okay. I think very clear regarding the assignment, the submission. The due date for submission is 14 June. You have plenty of time. 14 June is 7 weeks from now. Okay. You divide the work within your group members. I suppose you guys can meet each other in any application, Zoom or Skype. You just divide the thing and ask them to do separately. In case if you want to use handwriting for maths, I think can allowed, but give me a neat writing. I prefer typing. Okay, this time I prefer type thing. Use any application in the Word for typing. If you are doing handwriting for maths, you use that application, take a snap and take it, convert it as a PDF. That is regarding assignment. I hope it is very clear, and I hope you can do within the time frame. Now let us move on for today's lesson. Today's lesson is, before today's lesson, give me some time, I need to do some setting. Okay, today we will learn chapter 6, integer linear programming. Quite easy chapter because you all already have a knowledge of linear programming. Okay, how to solve a linear programming. Look at this example. Look at this example. I give you 5 minutes or a little bit more. You read this example and try to come out with the LP model. Try to come out with LP model. Just roughly write somewhere. I mean, you know, for now you already expert in getting the LP model. Now this is the time for you to test yourself. Read this. I give you 5 minutes. Come out with some LP model. There is 3 constraints. So start reading and writing the LP model. I give you 5 minutes. Okay, I suppose you guys have construct the LP model. This is the LP model in case. Okay. First one is 2 million. Acebond Realty has 2 million available for the purchase of new rental property. So they have 2 million. They want to purchase some property that would be townhouse and also apartment. Each townhouse costs 282, apartment 400. That would be the first constraint. Funds available. Of course, I divide by 1000 here, simplified. The second constraint would be townhouse is only available 5. Only 5 are there. That would be a second constraint. I write it here, T less than or equal to 5. Third one would be hours. The manager can devote up to 140 hours. Townhouse need 4 hours. Apartment in 40 hours. That would be here. I have written, the order doesn't matter. You can write it whichever order you want, but I have written the constraint like this. Now, before we move on to integer linear programming, solving integer linear programming, let us solve this linear programming as normal. How we have solved this in mathematics. So if you solve this by normal linear programming, you will get this kind of graph. This is the graph. This is the feasible region. Optimal value for you is 2.489 and another one is 3.252. This is the optimal value. This is by using normal linear programming method. If you draw, you will get this answer. This would be the optimal solution. This is the optimal value. Now my question is, when you solve this, your townhouse show that 2.479 and an apartment show that's 3.252. Now remember, this is a townhouse. You cannot buy 2.479 townhouse. Okay, this it must be in integer. It's a round figure. It must be a round figure, whole number. So this is theoretically whatever we have done here is right. Theoretically, by theory is right. But when it comes to real world situation, we have to manipulate it a bit, manage or adjust certain values there. So how are we going to adjust certain values here? If we use normal linear programming method, we will round down. Remember this, round down. You cannot round up. You have to round down to make it a single integer, make it a round figure. You have to round down. You cannot round up because if your optimal value is here, if you round up, your value going to be outside the feasible region. If it goes outside the feasible region, it is no more a solution. So you need to round down so that it goes inside the feasible region. Then only it's the solution. Okay, that is the reason I asked you to round down. You round down, you get t equal to 2, a equal to 3. Once you get a equal to 2, t equal to 2, once you get t equal to 2, a equal to 3, you replace inside the objective function, you get 65. Now, as a manager of the company, you're having a meeting and you're presenting all these things. And one of the member asking you that, is there any method we can improve the profit? The profit you're supposed to get theoretically is 73. But since you adjusting to the real world situation, you are getting 65 only. But the question is there any method we can improvise this profit going near to 73? Is there any method we can increase this 65? Go to near to 63? The answer is yes. That is called as integer linear programming. That is the reason we are learning integer linear programming. Now we are going to solve the same solution with integer linear programming. The question changed a little bit. This was the question for normal linear programming. For integer linear programming, you will add two words, and integer, the red color. When you add an integer, this is the whole problem now is integer linear programming, ITL. Okay. If the word doesn't appear here, this is known as normal linear programming. Okay. There's another word for normal linear programming known as LP relaxation. I will come back to this later. For the time being, what you have to understand, whenever you see these two words, you need to know that you have to solve this by integer linear programming, which we're going to do now. If you don't see these two words, then you have to solve it by normal linear programming, where you will end up with some decimal numbers. Now let us solve this n integer linear programming with the n integer. When I say n integer, t is integer, a is integer. Both quantity are integers. So how are we going to solve this? Let us do this. Example 1. This is the graph you saw just now in the slide. This is the graph, same graph. Okay. So if you use normal linear programming, this is the result you get. Now, for us to start integer linear programming, let me erase the feasible region part. Okay, I want to erase this, but you have to know that this is the feasible region. I suppose you know where is the feasible region now. All right, now for us to start integer linear programming, first of all, what you have to do, plot all the integer points inside the feasible region or on the line. That's what you have to do. When I say plot all the integer points that start from 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, and 5, 0. Sorry, let me use other color. Use different color so that it is more visible. You start plotting 0, 0, 1, 0, 2, 0, 3, 0, 4, 0. Of course, the number here start from 0, 1, 2, 3, 4. 1, 2, 3, 4. This one is 0. Okay. So once you plot this, next go to the next integers. 0, 1. 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1. All are integers. Can you plot here? Can you plot here? You cannot plot here because the coordinate here is 1 This is what? 0.4, 0.4. I don't want decimal number. We don't want decimal number. We want only integers, whole number. So we cannot plot in between. That's why I say plot in the integer. Whole numbers only. After this, where you go? 0, 2, 1, 2. And here. And then that's all. That is all the integer solution for your problem now here. Okay. Now, after you plot, normally what you will find the objective function, isn't it? So our objective function here is 2, 3. I readily plot, draw the line already to save time. So this is your objective function. In normal linear programming, what you will do, you will raise this line to the corner points. Am I right? So if you raise this line, where's the corner point? Highest corner point, go until here. This is the optimal solution you have. Okay, the optimal solution you have here. I have plotted here in the graph. You can see this is the optimal solution. How we get this? But for integer linear programming, we don't solve by corner point. We go by integer solution. Okay, you will focus on the point you plotted inside the feasible region. Okay, what is the solution? When I increase this line from 2, 3, when I increase this line, red color, from 2, 3, what would be the highest point it touches? Okay, let us see. If I increase this, look, focus on the plotting point only, not corner point, the blue color axis. When I increase this, which is the highest blue color axis touch the red line? This is the one. Let me repeat again. Once you plot the point, you raise the line as normal, but you don't go up to corner point. You go up to the maximum furthest point inside the feasible region, the plotting, the one you did. So if I increase this, the furthest plotted point which touches the red line is this one. Okay. This is our integer solution. What is that point? 4, 2. That's it. You found the answer. That is the integer solution. Okay. Furthest point. Now, if you take this point, okay, I have given you here. This is the optimal LP relaxation. Normal linear programming solution is here given here, and this is the one we found just now. Optimal integer solution. How I found? I just now show you how I found. So t equal to 4, a equal to 2. Take that value. Replace inside the objective function. You get 70. Now, for LP solution, which is a normal solution just now, you get 2.479, 3.252. That gives you the profit of 73574. And then what we do? We round down. See whether getting better alternative or not. We have to round down. Why? Because we are manipulating for the real world situation. We round down, we get 2, 3. What is the profit we get? 65. Is this the better solution? Answer is no, because integer linear programming here gives you a much more better solution. When you do the solution is 4, 2, the profit is 70. You can compare now. 70 is much more nearer to 73 compared to 65. That is the reason we use integer linear programming. So for you to find any solution in integer, okay, which means you cannot split the things like human beings. You cannot find 2.5 human beings. And that one you have to use integer linear programming if the question asks you to do. Okay, it is a better solution. So you can see the differences here: 73, 65, 70. Normally, I will ask you to give some comparison with 65 and 70. Once you find the 70, you give the comparison by writing like this. The solution obtained in B by rounding down is not equal with C. 4.2 gives higher optimum value than optimum value determined by 2.3. Some explanation like this, telling that you understand what you are doing. Now this is called integer linear programming. The main thing is you need to plot the line and move the line, plot the points and move the objective function where it touches the furthest point from the origin. Okay, this is how you have to solve integer linear programming. And integer linear programming, they will, you see, look at the exercise 1. How you know this is an integer linear programming? How you know? By looking at this word, an integer. This is an integer linear programming. Why? Because the word an integer. Now, when they give you this, when the question gives you this, and then the question asks you to determine the optimal solution to the LP relaxation. The word relaxation here, don't get confused. The word relaxation here is actually the question require you to solve it as normal LP model. The normal linear programming is another word for LP relaxation. Okay, that's why the solution is like this. Okay, the one you do normal, the one you do in the mathematics, that is known as optimal LP relaxation solution in integer problem. Okay, so if the question asks you LP relaxation, you do as normal linear programming, solve as normal, find the optimal value. If the question asks you to find integer linear programming, then you plot the points like this and find the optimal integer linear solution. Hope you guys understand. This exercise we will do later. This one we do later if we have time. Okay. Remember, an integer means x1, x2 are integer. Now, we are going for the second part, known as mixed integer linear programming. Mixed integer linear programming is actually like this. Same thing, but they give you this and x1 integer, which means only x1 is integer. Okay, x2 is not integer. X2 can take decimal places. I repeat, if an integer, then x1, x2 both are integer, and this is known as integer linear programming. If only x1 integer, then x2 is not integer. X2 can take any decimal places, decimal points, decimal numbers can. If x1 only integer, then it is known as mixed integer linear programming. Is it clear? Now, as usual, illustrate the constraint for the problem with a standard scale in sketching. Determine the optimal solution to the LP relaxation. So what is LP relaxation again? It is a normal linear programming model. Solve it as normally. how you solve normal in mathematics. Okay, so when you solve this, you will get like this. When you solve this, you will get like this. This is the graph, and 3.14, 2.6. That is the solution. Next question. Round down the value of x1 to find the feasible mixed integer solution. Okay. Round the value of x1 down to find the feasible integer solution. Now, just now this is the optimal solution. I replace this objective function, I get 14.08. When you round down x1 only, you get 3. Why we rounding down x1 only? Why not x2? Because we need x1 to be integer. X2 can take any decimal places, any decimal points. Okay, that is the reason. How I know x1 is integer? Because it is given in the question. Only x1 is integer. X2 can take any value, any real value. So when you do this, replace inside the objective function, you get 13.8. Now question is this 13.8 is the best profit you get? Because you're supposed to get 14.08, isn't it? By theoretical, this is the maximum you should get. But since for the real world situation, we do some adjustment, and the profit goes down. Is this the best thing? Answer is no. We have to solve mixed integer linear programming. This is a little bit slightly different from the previous one. Now let us solve this. For exercise example 2, so if you draw this graph, you will get example 2 like this. Okay, this is example 2, exactly the same, like this. Now we are going to solve mixed integer linear programming. How are we going to do that? To do that, let me erase the feasible region. Okay, mixed integer linear programming, little bit different. You don't need to plot, but you have to draw a line. Just now x1 integer, isn't it? So draw a line from x1 like this, vertical line from x1. Why I'm writing from? How I know from? I have to start from here because x1. Look at the x1. X1 is horizontal. They said x1 is integer. You start from x1. Mute your mic. Somebody open the mic. Mute your mic. You see, there's a background music now, background sound now. There's a background sound. I don't know how this background sound comes. See, that's why. Anyway, you guys can hear me clearly? Can you guys hear me clearly? Please say yes, no. Okay, okay. Now, once you draw the vertical line, see x1 integer, I draw from x1 vertical line. What I want you to focus is the peak of the line. Focus here. Can you focus here? Now I readily draw the objective function already. If I raise this line above, I want you to focus which peak, the one I circle, which peak touches the furthest. Okay, focus. And go until here. You see? I repeat. I want you to focus the one I circle here, the points I circle here. This point, these points. Circle these points. All these points. This one. Hope you can see. Let me use some other color. I want you to focus on this point. Okay, this is a point, this point, and this point, this point. There's another one here, this one. Okay, focus on this, the one I detailedly have circled. When I raise this line, look which point touches the red line, the one I'm moving furthest. That would be this one. Okay, you understand? So this is the point. So your solution is this one. This would be the solution. Mixed integer linear programming solution. That would be, for sure, your x1 is 3. Of course, little bit the thing is not perfectly touching the 3, but your x1 is 3. X1 is 3. Okay, x1 is 3. But what would be your y? If you look closely, this x equal to 3 touching the, which line it touch? C1. It touching the C1. Okay, it's like this. This part I'm redraw here. It goes like this. We want this point. We know this is 3. This is 3. We know this is 3. This one is C1. We want this point. This point. What is this point? We know x1 is 3. C1 is here. Replace. We know x1 is 3. X1 is equal to 3. Somebody someone didn't mute the mic. I can still, yeah, okay now. The sound is there, still there. So x1 is equal to 3 and it touches C1. You replace x1 inside here and you will come out, you can get the x2. X2 is 2.67. So our x2 is 2.67. Okay. This is our x2. And if you replace that inside the objective function, you get 14.01. Okay, that's how you solve the question. That is the solution. You can see here. I have redraw here in the graph. This is the vertical line. And if you bring the objective function to here, this is the point. Optimal mixed integer solution is 3.32.67. You replace this point inside the objective function. you get 14.01. You see here just now, LP relaxation solution, the normal one is 14.08. You round down, you get 13.8. You do mixed integer linear programming, you get 14.01. So 14.01 increment from 13 is better value. Okay, this mixed integer linear programming gives you better profit. Okay, 14.01 almost near 14.08. Okay, that's how you have to solve mixed integer linear programming. And of course, some explanation. You can see my slides later how to give some explanation. If at all I'm going to ask this in the exam, I'm going to ask exactly the same thing. Okay. Now, I have teach you integer linear programming, ILP. I have teach you mixed integer linear programming, MILP. Both I have taught you. Left is 2 exercises. I will come back to that. Hopefully we have time. Now I'm going to teach you how to get the solution from prompts of the software, so that you can check your answer. Go to module. Go to module. Look at here, integer and mixed integer linear programming. Integer and mixed integer programming. Click here. Go for new. Constraint, you can put 3, variable 2. Okay. Now let us solve the first one. See whether we get the same answer or not. This would be T. This would be A. 8, 2, 4, 1, 400, 40, 0, 2000, 140, 5. Okay. Once you enter, this is example 1 is, remember, an integer. T and A are integer. So this is integer linear programming. Make sure you click here. You see there's a one portion here. You can select integer or real. Click T integer, A integer. Solve. Graph. Now you can see that solution for integer linear programming 4, 2. This is one 4, 2 and 70. 4, 2 and 70. Okay, the solution is here. LP solution is the one for the one we did on the beginning. This one 2.479, 2.479, 3.2 is here and 73 is here. That's how you check the answer. All right. So this is how you use POM software. Let us now use for mixed integer linear programming. This is mixed. Go back. Here x1, x2, 2, 3, 4, 7, 9, 5, 36, 5. Okay, here you can see x1 is integer. X1 is integer. And x2 is not integer, isn't it? So this x2 you can write it here real. Okay, x1 is integer, x2 you can write it as real because x2 they never require you to give x2 as an integer. So x2, if they never require you to do that, you click here real. X1 only integer. Solve. and you can see here our optimal solution mixed integer linear programming x1 is 3, x1 is 3, 2.67, 2.67, and the optimal value is 14, 14. This one is LP solution, the one we found before this. You can see 3.4, 2.6, and 14 is here. Okay, that's how you solve. Now we still have time. Let us start to exercise 1. Exercise 1. If you draw this inside the programming, five, 8, 6, 5, 9, 1. 30, 36, 10. Both the integer, change integer, solve it. Okay, so this is how you get solution. Now let us do on this. This is if you draw the graph, if you draw this graph LP relaxation, you will get this kind of graph. This is your objective function. You will raise it. You will raise, but you won't stop here. There's another one. This would be your this point here is your this point here is your LP this point here is your LP relaxation solution. What that point would be 1.43, 4.29. This would give you 41.43 profit. Okay, this is LP relaxation solution. Now let us move on to solve this by integer linear programming solution. How are we going to solve this? I want to remove all the lines first. Now plot only integer, no decimals, small one, okay, that's it. That's the integer. Now let me Let me remove this so that it has a clear. Yeah. Now, if I raise the line, now focus on the plotted points. Each point is touching the plotted point. That would be here. Okay. That would be this one. This is I solution. That would be 0, 5, and this would give you how much it would give you. It would give you 40. Okay. The objective function is 40. For LP relaxation is 41. Of course, you can do by rounding down. Okay, you can try. Later, you can try. If you round down, you will get 1.4. You try in objective function, it must be, I don't know whether maybe same with this or less than 40. Okay, this is how you solve exercise 1. Let us move on to exercise 2. Exercise 2 is this. X2 is integer. X1 is not an integer. Okay. Double check. Solve. This is a solution. So go for this. This is your exercise 2. If you draw this, you will have this kind of graph. So if you increase this, for normal solution, this is the objective function, you increase. You increase up to here. Okay. So this would be your LP solution. That would be 196 548 and 743. This is the answer. 743 is the objective. It is the optimum value once you substitute inside the objective function. Okay. Now let us find the mixed integer linear programming. So for that, let me bring down the line and erase all this line. Now, which one is integer? X1 or X2? Now, X2 is integer. So, X2 is integer. You have to draw a horizontal line. From X2. Okay, that's all. Now, I suppose you know where to see now. The peak would be focus here. This one, out of this one, and there's another one. Out of this one, you have to know which one, if I move this one, this line, focus on the one I circle, not the LP relaxation formula solution. That would be here. Okay. That would be this one. Mixed integer linear programming solution. We know that this is 6, but this one we don't know. Okay. If you look closely, the 6 is here and it touching C1. Okay, we want this point, isn't it? So it touches C1 and X2 is 6. X2 is 6. C1 is this one. Replace X2 inside the C1 and get X1. So your X1 is, the solution for this is 129.6. Okay, and what is the you can see here, you see 1, 2, 9 and 6. The optimal value is 7.29. So this one gives 7.29. This is the answer for exercise 2. Of course, you can do by rounding down. This one you can try rounding down. So with that, that's all for today. I have finished chapter 6. I will give some exercise for you to do, And if any question you can ask me. I hope you are very clear with the assignment. All the materials I will upload in the Google Drive and give you a link for you to download. Okay, till then I'll see you next class. Till then, take care and stay safe. Thank you very much for your cooperation. Bye bye.